And Professor Market is visiting us for 2 days. And actually we have a long time background of very successful research collaboration, which originally was initiated on some personal level. And nowadays our task is somehow to facilitate this process and try to establish some interinstitutional cooperation between our academy and the Institute of General Mechanics and the Technical University of Aachen. Today Professor Market will give us a lecture about the University of Aachen and also about the industry 4.0. And our task here, the task for everybody, is just to look for possibilities to develop some future projects. And after the discussion here, we can still stay with Professor Market. We can discuss more closely some specific topics, specific projects we can develop together in the frame of with the help of DFD funding, DAAD funding, and probably with the help of some other resources.
Профессор Бент Маркет представляет технический университет Аахена, является директором Института общей механики. И он сейчас у нас сидит там 2 дня для того, чтобы промониторить наш университет, рассказать о возможностях, которые они нам могут предоставить в университете, с техническом университете города Аахена, который является одним из топовых университетов не только в Германии, где он входит в пятерку лучших университетов, но в Европе котируется как один из лучших университетов Лиги университетов мировых. И является механика, общая механика, прикладная механика, это в чем они являются лидерами в Европе. И профессор Маркет здесь, чтобы рассказать о возможностях университета, что собой представляет университет, какие возможности они могут предложить нам, не только в общей механике, но и вообще по тем направлениям, которые есть в университете. Это и в архитектурное направление, и даже есть экономическое направление, но связанное с производством, и с тем, чтобы мы могли найти, обсудить общие точки соприкосновения в исследованиях, в учебе для обмена студентов, и могли предложить, то есть могли обсудить наши возможности в сотрудничестве с университетом. А также сделать небольшую презентацию по направлению, которым они занимаются непосредственно. Это так называемая 4-я индустриальная промышленная революция, то есть связанная с 3D printing, с диджитализацией, так называется, digitalization, so I could just add it to Vlad, so to Mr. Danishevsky's introduction. С тем, чтобы мы могли объединить, то есть обдумать наши возможности исследования и обсудить это с профессором Маркетом.
So, thank you very much. So, dear Vlad, dear Julia, and dear colleagues and also students, it's my pleasure to be here and to give you some overview of my university, my institute, and some of the research subjects we are working on. Of course, you will directly see that my university is a little bit different to your state academy here, but actually that just give you some idea about what is possible, and of course I hope that we can start with a very nice collaboration and with student exchange, but also with exchange of researchers, so that PhD students are coming to us, so that we also can send our teachers maybe to him. So let me start briefly. So I will start with RWTH Aachen University in general. And I'm not a fan of all these kind of rankings, but when you look into the international rankings, you will see that Aachen is on some top positions, especially when it comes to mechanical engineering. But I'm not that much a friend of these kind of rankings. For me, it is more important to give you an idea about what the university and all my colleagues can do together. And for this I have a short video. Just a second. I'm not that keen on numbers, but just to give you an idea about the size of the university. So we have currently over 45,000 students, and out of these 45,000 we have more than 10,000 international students. So we are very attractive to students from abroad, and there I do not just mean the European countries surrounding us, it's also China, India, and from all over the world. Then, when it comes to the budget, because you saw that video, and this was the new part of our campus, the university has about 1 billion euros plus 1 billion euros for the university hospital. So in total about 2 billion euros budget per year. Yeah, and 50% is from the state, and 50% is third-party funding from industry, for instance. So in principle, we are a full university, so we have in total 90 faculties, from medicine up to, let's say, natural sciences, mathematics and so forth. But the core part of the university is engineering. So there's civil engineering, mechanical engineering, georesources and materials engineering, and also electrical engineering. So it is not just the university, there is a certain kind of ecosystem surrounding the university. So and here you see some of the institutes closely related to the university. So these are 4 Fraunhofer institutes, but also the Jülich Aachen Research Alliance, or certain other institutes like Leibniz institutes and so forth. So this is what you saw in the video. So this is the new part of the university campus. In total we have 3 campuses. One is in the city center of Aachen. This is Campus Melatna, this is Campus West, this is a new area. And this is what you saw in the video, yeah, from the bird perspective. And all these buildings have been built up in the last 5 years. And this, what is important about that, this is not state funded. This is funded from private investors. What is important is when this is finished, so investment is about 2 billion euros, but private, yeah, not state. when this is connected, then this has 2.5 square kilometers of campus area, which is the largest technology-oriented campus in Europe. And due to this investments that are made, of course, we are very good connected to industry. And these are just a few companies with whom we cooperate. So let's say with the money of the industry, we can set up all these facilities. So it's not state money. So here, some aspects about especially mechanical engineering. So with about 13,000 students, we are the world's largest engineering school in mechanical engineering. And of course, there are some other numbers. So we currently have the highest number of students at the RWTH Aachen University. And so the most common reason why students are coming to Aachen is, of course, the reputation. So when it comes to the students, about 50% are in bachelor studies, and over 50% are in engineering, and another quarter here is in natural sciences. So we are really a technical university. So now, this is me. I will talk a little bit about my institute to give you an idea about, let's say, what means fundamental research in this context. Okay, so my institute, the Institute of General Mechanics, was founded or existed since the foundation of the university in 1870. So next year we will have the 150 years anniversary of the university. And if you look back into, let's say, my predecessors, then of course there are some famous guys included. So for instance, this one, I'd like to mention that one here. Theodor von Karman is one of my predecessors in the long history of directors of the institute. So, and just to give you another number, which is not listed here. So the institute has between 50 and 60 employees, and is with this one of the largest mechanics institutes in Germany. And we have a budget of over 4 million euros a year. Okay, and this guy you know. This one here. Yeah? He's sitting here. Yeah? And of course we have a long, let's say, partnership, and I would say friendship, because he got the Theodor von Karman Fellowship in 2014-15. When was it?
Last year.
It was last year?
Yes.
So it was, okay, 18. Sorry, no, yeah, 2014. Yeah, so we started with a project funded by the German Research Foundation, the DFG. Yeah, this was the starting point. Yeah, you see nonlinear vibrations of heterogeneous structures, internal resonances, and modes coupling. So this is favorite subject. Yeah, we started with this, and out of this we made this one, and now I'm here, and we try to start further collaboration. So, and I'm not just professor to do research, I'm also professor to do teaching, and this is me in front of class. So I'm teaching engineering mechanics for mechanical engineers from the first to the third semester. We have mass lectures with 1,600 students, so this is really one of the biggest auditoriums that we have. It's fully equipped. And so since 2013, I started in 2013, I had more than 30,000 students in my lectures, and I had to take more than 21,000 exams. So the question is always, how can we do that? So here you see again the lecture hall, yeah? And there we do not get all the students in one lecture hall, so we have two of this size, and we have video transmission. But the question is then, how can someone sitting in the last row, or even in the other room, ask me a question? And this is what we do digital. Yeah? So we have an own application, where they can, like WhatsApp, they can send a message and it pops up on my screen, and then I can answer the question. So moreover, we have, of course, we have teaching videos. So this is not me, this is one of my colleagues, and he's then explaining certain things about mechanics, so that the students that cannot be present in the lecture, they can look to the videos, and then of course the exams and also the homeworks and assignments are done in such computer pools, so where you have 600 computers to do the electronic exams, for instance. So this is now something she has to translate. So that is now because I talked about engineering mechanics, so a very fundamental mandatory course in mechanical engineering, but also in civil engineering. So, and here this is the result of a recent study. And in this study, they asked CEOs of mechanical engineering companies and also university professors and so forth. What do you think is required, or what is one of the required competences to do projects in Industry 4.0? And the result was, okay, engineering mechanics, number one. Yeah, so you need fundamentals. And then simulation and modeling. I try to translate that a little bit. Yeah? So if we accept that Google knows everything, right? Nevertheless, you have to ask the right question. Or let me put it like this. My young students, they ask me, okay, is it okay to study an engineering subject? Wouldn't it be better to study computer science? And then I usually tell them, look, software cannot fly, not swim, not drive. You need the technical system. You have to produce the technical system. Yeah, and this is the job of an engineer. Yeah, and of course that we need software in the technical product is clear, but software alone is nothing. This brings me to some examples that show you how you can use that knowledge coming from mechanics and combine it with information technology and, let's say, artificial intelligence. The first example is what you see here is a quite old, I would say, milling machine, yeah, a machine tool. And we retrofitted this machine by plugging some sensors on it. From the data that we get from the sensor, we can predict whether there is a problem with the machine. So, and this is a signal of such a sensor. These are vibrations. Then we use methods of artificial intelligence to evaluate the data. And then we can predict in advance when, let's say, the tool has to be replaced. These are just some more details about that, which I don't want to explain too much. So at the end of the day, what you can do with the data, if you have data, you can compare the, let's say, the healthy state and the somehow damaged state, and this helps you actually to do maintenance. I can give you another example. So this is a typical production of wire bonding. So you use ultrasound to combine cables. The problem here is you have to guarantee that the cable, of course, bonds, that they bond together. So we implemented a sensor, recorded again the same data as before, and could now predict from this, let's say, data whether the bonding is okay or not. So this is now a very important subject in electric mobility. And here is a video of the production process.
Да, это видео, как это все делается.
And then they are combined, so it's welded.
Да, при помощи сварки, то есть это все вместе сваривается.
So typical production process. So let me give you another example. Let's stay with the automotive industry. But you can also apply that to civil engineering, doesn't matter, to production of buildings and construction of buildings. So typically you have some top requirements that need to be fulfilled. That is, when it comes to a car, for instance, that is maximum flexibility, comfort and safety. To cope with this problem, of course, what you need is, you need new designs, new materials and certain integrated services. And to do that, yeah, since you cannot build too many prototypes, you need modeling and simulation. So you like to virtually test everything in advance. I give you one example. So this is a spider web, a modeled spider web. And this spider web is impacted by an insect. So this is not a bullet, this is an insect. Yeah? And we were able to model spider silk virtually, coming from molecular dynamics up to, let's say, a real spider web. So what we then did is, we thought about what happens if an airbag is made out of spider silk. Yeah? And we tested it. So we took this model, simulated an airbag with a head impact, and spider silk airbag behaves much better than actually the standard airbag made out of nylon. So another example, how you can use modern technology to get ideas about new materials. So this is a fiber reinforced composite material. And what we were using is a so-called acoustic camera. So that's an array with over 100 microphones where you can then later on visualize where the fibers in the material are rupturing and damaged. Another example is in the direction of biomechanics, and that is something that you use for fractured bones. So the funny thing about this material that we are using is the following. For instance, when you have very thin bones here at the foot, then, and here's a rupture, a fracture, yeah, so then you can use this platen, but the problem is, at the end, when the bone is healed, you have to remove the platen. And then very often, in these thin bones, by removing the implant, you break the bone again, and that makes no sense. So the innovative thing about it is that these implants are made out of a magnesium alloy, and this is degraded in the body. So it can remain and it will be degraded over time, and this is what we can simulate. And there is a very nice, let's say, sentence from Leo Platt, which is the former CEO of Hewlett Packard. And he said, whatever made you successful in the past won't in the future. And I will explain that in a minute why. Let's have a look into ThyssenKrupp. This was one of the first steam hammers that has been used. And we call this the first industrial revolution, that we were using power machines. Second industrial revolution, Taylorism. Here you see again ThyssenKrupp, where they have the grass mower assembly. So next step was automatization, so that you have robots. Again here ThyssenKrupp, 1989. So now that's the question, whether this is the fourth industrial revolution. So that Industry 4.0, that means that you have collaboration between machines, that everything is connected and communicating, and that we use data actually to learn more about our systems. So now the question is, what is now different to, let's say, some decades before? What is changing? It is definitely getting faster, so we get new technologies. We get also the replacement of technologies very fast. We have high-speed traffic and whatever communication and stuff like that, but also automatization. So everything is getting faster. But at the same time, things are getting better because we have quality control. We have better product quality. We have better process quality because everything can be modeled. We have quality management. And of course, also the services surrounding everything are getting better. I'd like to give you an example about, because here is Amazon Prime. So but let us connect Amazon Prime with a car, for instance. So in the future, I first explain and then you can, because you need to get the big picture. So let us assume in the future there is no need that you have a car. You go to some platform like Amazon or whatever, or Google, doesn't matter, and you simply order, I want to go from place A to place B in this time, with this quality and with this comfort. And that is what you do. What kind of vehicle is coming, whether this is a helicopter or whatever kind of fancy thing, it doesn't matter. You simply order, I want to go from there to there, in this time with this comfort. And this will be the future. So that was just an example. But this is amazing that everything is getting cheaper. When you talk about materials, they are getting cheaper. Logistics. When you today order something at Amazon, next day it's there. So it's getting cheaper. So you do not have to pay extra for that. Then communication is getting cheaper. So we all have smartphones, right? Supplier prices are going down. So everything is cheaper. So finally, everything is getting more transparent because you can always look in the internet or wherever. How is my competitor behaving? You have standards, you have some codes, and of course also company data is available, at least in Germany. I don't know how this is in the Ukraine, but everything is transparent. So, and now the question is, what is the implication for education? And I like to give you this quote here. So the Chief Financial Officer, CFO, asks the CEO, what happens if we invest in developing our people and then they leave us? The CEO says, what happens if we don't and they stay? So it's not just about that technology is advancing, so also our people have to advance. And there, in an academy or at a university, this is our job, to do that. And this actually would be the job of my colleague, but actually he could not be here today, so therefore I will say something about the International Academy, which is the Academy for Further Education at our university. So, and I'd like to give you some ideas about that. So, they are directly oriented here or located at the production cluster on this new campus. So we saw these buildings before in the video. And they try to bring together the knowledge that is in the university towards industry or study programs and so forth. So they are transformators. That means we have innovations at the university, we have new technologies at the university and Fraunhofer. We have laboratories at the university, but also at Fraunhofer. And now, demonstration factories, but now the question is how can we bring this towards industry? So now, what are the target groups of the International Academy? So one thing is, of course, young professionals, that these are really students, so master students, let's say. Mid-career, that you bring to them new technologies, or senior career, that you tell them, okay, how to handle these new technologies. And depending on that, of course, we have here, these are people that are already in industry, these are students, and of course this is the transformation of university knowledge into industry, and this is paid by industry. So this is not for free, so this is not state-owned, this is a so-called non-profit limited. And of course, now the academy has different formats, so this is now for the students, So these are privately organized master's programs. So this is especially for international students, non-European international students that come from India, Pakistan, US, wherever, and they pay for their studies, but for this they also get everything in English, and everything is well prepared. And on the other level, we have so-called summer and winter schools, where, let's say, students from abroad, but also people that already stay in companies, can get an up-to-date knowledge in, let's say, automotive and mobility studies and so forth. Structural engineering, you see that, or certain other certificate courses. And this is especially for industry. These are so-called certificate courses. Where you see there is a lot of Industry 4.0 kind of stuff in it, So from management, but also towards, what about industrial big data, for instance, or communication 4.0 and stuff like that. So, but also up-to-date things like 5G, This is required for the Internet of Things, You need 5G, but people do not know what is that and what is required, and then they learn. If they actually, of course, when they do a master degree, then of course they get an official certificate, but they also get a certificate if they, so an official RWTH expert certificate or executive certificate if they attend these certificate courses. So it's value for them, and therefore they are also willing to pay. Sometimes the company pays, sometimes let's say the people themselves.
And what are the question is, so what are the prospects for a master? So after obtaining the certificate from the academy.
Are we talking now about the master degree or the certificate?
So certificate, about the certificate.
So the certificate shows that the candidate is able or knows something about modern technology, and this is worth for the company.
My name is Oleg Kozlov. I represent the Material Science Department. Thank you for very interesting lecture. And I have a question about the master programs. So, as far as I understand, for foreign students, they should pay for master degree. But
so there's a difference. So we have the public system. This is for free. But there everything is in German. The study programs are in German. So now when you come from India, then you cannot speak German, right? So, and it is outside the European Union, so that means also the parents and so forth, they did not pay tax to the social system and so forth, right? So therefore, they charge the students, I don't know, 5,000 euros per semester, something like that. And this is around the price what a standard student costs in Germany. For not for medicine, but for standard engineering. Yeah. So it's non-profit, yeah. So but they have to pay the teachers and stuff like that.
I see. So the master programs in German are free.
Yeah, they are free.
Master programs on English. They
This is the system
And
that
also
we
bachelor
have.
degrees, so there is another question. So
that-
there is a similar system.
We do not have the private part for bachelor.
Sorry, question. Does Aachen University have some online courses on different platforms?
That's a good question. So of course we are also observing things, especially in the direction of the United States, MIT, Stanford, and so forth. But MIT and Stanford, they started with edX. Maybe you know that platform. We also paid a lot of money to enter edX, but then we saw, okay, the MIT and Stanford, they do not make money out of that. Because, of course, people try to download the courses, but they do not want to pay for the exams. Yeah, so there, you can watch the video, but when you want to get the exam, to get a certificate, you have to pay. Yeah? And students are not willing to do that. Yeah? And then there is another problem with the teachers. Let us assume that Stanford or MIT provides a perfect lecture on video or online for engineering mechanics. For what do they need me then? Yeah. So then they can actually get rid of my job. Yeah. So that's also the thing. Yeah. And then, of course, when you come into my lecture, you will see that the students are there and they are not playing with their smartphones. They are listening what I'm telling them. And this is really, so university is not digital. I would say university is that we sit together, that we talk together, that we feel what is university, what is academia and stuff like that. Yeah, so you cannot replace everything by digital means. It's not possible. Yeah? And this is my deep, let's say, opinion on these kind of things. Yeah? So we should have a nice university and a nice framework for the students. Yeah? And provide them, of course, with digital kind of media and stuff like that. Yeah? Such that they can learn better. But we should never close university. So think about everything is digital. For what do you need that building? No chance.
But many startups platforms that you can get some money for the certificates, like future learning.
Yeah, sure. But at the end of the day, you want to have the people present, right? Because we need them to do research. Yeah.
So there are no courses from our.
No, what we try to do is that we have preparation courses. Yeah. So that sometimes maybe they do not get the admission, and then they have to take some extra courses in advance to get the admission, and they are then online. That makes sense. Yeah.
The question is about the translating experience, taking experience to Ukraine. Teaching languages because the professor is wondering how it is possible that people in the European Union speak their mother tongue and another language at a proficient level, and what is the system of teaching foreign languages in Germany? What is your experience?
So it starts very early in school. So when they do this, I think in US it's baccalaureate or something like that. So in Germany it's Abitur, yeah, so high school diploma. Yeah. So there, when they enter high school, they very early learn, let's say, English, and then I think 2 years after they enter, they learn French or Latin or whatever language. Yeah. So they have 2 foreign languages.
So if there are any programs, bachelor programs in the public sector in the University of Aachen, and do you know also what are the requirements to become?
That depends on the study program. Yeah. So of course, what is required is German language skills. yeah, because everything is in German, yeah. And then, of course, it has to be, so in Germany is after high school you get a diploma, yeah. They need something comparable. Yeah.
And do you know if our certificate, admission certificate, so external, testing assessment, which is an equivalent to GMA in the United States.
We have to look it up. If, for instance, we can do that for civil engineering, for architecture, then we can look. I can send it to you. Yeah, I'm not pretty sure whether this is in English. That it's only in German. Yeah, so the regulations for the admission. Yeah, everything is stated, and these are the rules. Yeah, and then we have the international office, and the international office is checking the general, let's say, admission requirements of an applicant. Yeah, so you can formally apply. Yeah, and then the international office checking everything. Yeah, and if the certificates are based on common standards, then you can study there. Yeah.
I'm sorry. And if I've got the point, so your video lectures are supplementary for lecturers in auditorium. Yeah, it's not enough for students just to watch your video lectures and then pass the exam. Yeah.
No. So students need not to be present in lectures.
Okay.
But they can. Yeah, of course they should. In my case, they attend. Yeah. But I have other colleagues, so I don't know, they just read out of a book or whatever. I don't know, or just show slides without any interruption. Yeah. So 5 or 7 frames per second is a video, right? Yeah? And they just click, and that makes no sense, right? Yeah. Sure. But at the end of the day, there is no need that they show up in the lectures, so they can also do that within self-studies. Yeah? Yeah, like an autodidact, so no problem. Yeah, that is possible in Germany. But in the exercises or practical exercises, they have to show up. So there they have to put a signature.
Oh.
Yeah, sure.
My name is George, and I'm the first year student of mechanical faculty. And I have a question about the work. So, will the foreign students have an opportunity to work during the studies, or is it allowed for everyone?
Okay, so that's also a good question. So you know that living in Germany is not that cheap as here, yeah, and especially cities like Aachen are very crowded, and to find an apartment is not that easy. So you need some money, and of course the university offers the students to work as a student assistant, yeah, and so different institutes provide these kind of jobs. And this is of course possible to do that. This is also possible with English language, no problem. So whenever it's a research institute, everybody speaks English, no problem. Yeah.
And the question is, do you have a direction in 3D printing in civil engineering and construction?
Yeah, so I'm a civil engineer actually, yeah, and but I'm not working in the faculty of civil engineering. But I know that the architects, so one of the architects has more robots in her, let's say, laboratories than some of my colleagues in mechanical engineering. And my colleague is using them actually for also so from an architectural perspective, to come up with new designs. Yeah? So because now you can, with the help of robots, you can design and build things that haven't been possible before.